Here is the next example. Here we have two energy storage elements, at the same time two inputs. By the way, this U1 and U2, those two are the current sources. If it is a voltage source, basically this is voltage source, and the current source is, you will see an arrow inside that source. Okay, that's the difference between voltage source and current source. That's how I differentiated here. Now here I have two energy storage elements, so I'll end up with two variables. I'm going to take this as x1, current, always take current passing through the inductor as one state variable. Voltage drop across the capacitor is another state variable. Is it going to make any difference if I chose this as x1, voltage drop across capacitor as x1? No, it's not going to make any difference. So it must be the same. I mean, your equations are going to be, instead of x1 constants, you will end up with x2 constants with the x1. Okay. Now, if you see a current source, you better apply KVL. I think it's easy. So now look at here. What is the current coming here? That current is U1, x1 is there. What is the current passing through the capacitor? That must be U1 minus x1. Okay, can I say x2 dot equal to 1 over C U1 minus x1? Excellent. I already have one equation, x2 dot equal to 1 over C U1 minus x1. So basically my x2 dot equal to minus 1 over C x1 plus 0 x2 plus 1 over C U1. That's my x2 dot. Now x1 dot, okay, so whatever the voltage across, so voltage across inductor, can I write this as L times, I'm going to write this as L times x1 dot, okay, equal to, I don't know that voltage, let me take that as VL, voltage drop across inductor. But I shouldn't have another variable like that. It must be in terms of x1 and x2. Okay, now can I say my VL is same as what is the voltage at this point? That must be x2, because anyway in any circuit you will end up with 1 as a ground. So I have a ground there, so the voltage, so here it is 0 volts. This and this point, both of them are same. Ground voltage is 0 volts. So the voltage at this point must be x2. x2 minus 0 equal to x2. And what is the voltage at this point? It's same way, must be y. So can I say this as x2 minus y? Okay. Now even your state equation shouldn't have y, so we need to eliminate y. So to eliminate y, we will write down another equation there. So I know that x1 current is coming there and U2 current is coming there. So can I say my y equal to R times x1 plus U2? I can write down that. So if I substitute it here, this is my output equation. Okay, this is my output equation. Okay, so now I'm going to substitute this in here. So I'm going to substitute this in there. So L times, so x1 dot equal to x2 minus R times, basically isn't it L times x1 dot? Okay, that must be L times x1 dot. L times x1 dot equal to x2 minus R times x1 plus U2. Okay, so I can write this as minus R times x1 plus x2 minus R times U2. Okay, so if I put it as x1 dot, so over L, 1 over L over L. Okay, so my matrix A must be minus R over L 1 over L minus 1 over C, 0. My B matrix, you will end up with U1 and U2. So 1 over C, there is no, sorry, yeah, this must be 0. There is no U1 term, so minus R over L, and 1 over C, 0. That's my B matrix. Okay, and same thing, C matrix equal to R and 0. And my D matrix is going to be, you will end up with what is that, 0 and 1. Okay, I'll stop it here. Thank you.